All right, so today we are talking about factoring what's called difference of squares. Okay, so basically when we are factoring, if we can find this pattern of difference of squares, we can just go ahead and basically write down the answer so we don't have to go through all the steps of x factoring. So as you can see on number 1 here, we have x squared minus 16. So I can see that x is squared, and I also know that 16 is 4 squared. So I could rewrite the same thing as x squared minus 4 squared. So this is where the term difference of squares comes in here. There's a difference because it's subtraction here, and these numbers are both squares. So this is a difference of squares. So in order to factor this, I'm going to make a little note over here first. So if I have a plus b times a minus b, so this would be something that's kind of in factored form. Let's actually go ahead and multiply this together just to see the pattern that happens here. So when I multiply a times a, I get a squared. When I multiply a times negative b, I get negative ab. And then I'll go to this second term here, and b times a is plus ab. And then positive b times negative b is negative b squared. So this negative AB and positive AB, that middle term, that's going to cancel out every time when I have a positive here and a negative here. Those middle terms will always be equal and opposite if these terms are all the same, right? It has A in front in both of these, B in the back in both of these. So those two middle terms are always going to go away in that case, and you're going to be left with a squared minus b squared. So this is what we have up here. We have x squared minus 4 squared. So it's like the same type of thing here. And we know that if we want to factor it, we want to get it back to that form. So it's just going to factor to a plus b times a minus b. Okay. So I went the opposite way just to show you kind of where it comes from. But in this expression over here, a would be x and b would be 4. So I could write this as x plus 4 times x minus 4. So if I notice that pattern, I can just write down the answer is where we're going with this. Okay. So let's try another one. Ooh, I wonder if I can, clear it. Okay. Clear all drawings. Okay. So we've got x squared minus 9. Okay. So again, that is a difference of squares because 9 is a perfect square. And we, of course, have x squared. And so x is a perfect square. So I can rewrite this as x plus 3 times x minus 3, right? Because x squared minus 9 is the same as x squared minus 3 squared. Okay, so anytime it has that pattern, I already know the answer right away, okay, as long as I know what the square root of each of these terms is, right? So let's try another one. All right, so we've got 18n squared minus 8. Now this one looks a little different, right? 18 is not a perfect square, and 8 is also not a perfect square. But I also noticed that 18 and negative 8 both have a common factor. So I'm going to start by pulling out that common factor. So they both have a common factor of 2, or the highest common factor they have in common is a 2. So I'm going to pull a 2 out. That will leave me with 9n squared minus 4. Okay, now look at my two terms in here. 9n squared, that's a perfect squared because it's the same as 3n squared, right? If I put it in parentheses anyway. And then minus 2 squared. So a would be like 3n and b would be like 2, but we still have a 2 out front, so we can't forget about that. So this part that's in the square brackets here, that would factor to 3n plus 2 times 3n minus 2. And then that other 2 would just have to stay out front. Okay. So once we pulled out we couldn't see that they were perfect squares before we pulled out the common factor. But once we pulled out the common factor, then we can see that these two terms are both perfect squares. And if both of your terms are perfect squares and there's a minus between them, then we can just write out the answer. The square root of 9n squared is 3n. The square root of 4 is 2. So it would be 3n plus 2 times 3n minus 2. Okay, let's try another one here. All right, so I've got k squared minus 9. So k squared minus 9, and we've already done one like that. I'm going to skip that one. We've got 9r squared minus 1. So remember, 1 times 1 is 1. So 1 is a perfect square, and then 3r squared is also a perfect square, to be 3r squared. So I can write this as 3r squared minus 1 squared. So a is 3r and b is 1. By that I mean when I had my general form of a squared minus b squared, that factors to a plus b times a minus b. Which, by the way, it doesn't matter if I write it in the other order, it's still the same thing. I can write it like that as well, and they'll still be equal. So this is going to be 3r plus 1 times 3r minus 1. Okay, because I noticed that pattern of the difference of squares. Okay, let's go ahead and see if I can find the type I need to show you before I turn you loose to do your assignment. This one. All right, so I can see that 9b squared, that's a perfect square, right? That's 3b squared. And then 1 is 1 squared. So it is, these are both squares, but that it's not a difference. That is added. So because there's a plus in there, this is not factorable. Okay. So a difference of squares we can factor. A sum of squares is not factorable. Okay. So good luck on this. I hope that you try it out. And that it's no troubles for you. If you do have questions or need help, just let me know.